welcome back everyone. I hope you had a lovely half term and you're ready for some maths. First lesson Monday morning, exciting stuff. We are going to continue with the volume of cylinders stuff that we started with, but before we do, got a little bit of a logic puzzle for you to practice our bit of our metacognition, how we think about the process of thinking out a tricky problem. So this little puzzle here is called a Suguru. So the Japanese like inventing all of these things. So what's going on here is you can see the bold lines around. They need all the numbers starting with 1 that you could fit in there. So this has got 1, 2, 3, 4, 5. So the numbers 2, 3, 4 and 5 must go in there as well as the 1. In here we've already got a 4 and I've added a 1. That's because this is the only place where a 1 could be, because the rules are this. It's nothing to do with columns and rows this time. It's all about every number cannot be touching itself, and that includes diagonally. So if we've got a 1 here, there cannot be a 1 in any of these 8 squares that surround it. So we've got to have 1 to 5 all in here. It cannot, 1 cannot be there, there or there. They've put that one in, so I know that there's a 1 there. Now that sort of thinking can help us get through all of it. So I'm going to continue and show you how I would get through at least part of it. Pause the video though and see what you can do first. So the first thing I can see up here that I could do is 3, 3 and 3 can't go in there, so it must go in there, and we've got the other numbers from 1 to 4 going in there. Here there's going to be a 1 and a 2, so that can't have anything to do with the 3. At the moment, what else can I see? I know that the 1 can't go in any of those 3. So in this one here, the 1's got to go there or there. Now if it goes there or there, it cannot go here. Do you see what I mean? If the 1 was there, you wouldn't be able to put it in anywhere in this block. So for that reason, the 1 must go up there. And as there's only 2 here, I can then say that that is a 2 as well. Now, as that 1 is up there, now that excludes 1 from being here, so I know 1 must go there. And now that I know that 1 can't go in there, it can't go in there, so 1 is going to be in one of those 2 there. I know that much. And then similarly, I know that a 4 must go either here or here, because it can't go there or there. Now if it's going either there or there, you cannot have a 4 here. We already know we can't have a 4 there or there because of that one. So if there's definitely a 4 there or there, it can't be there, which means it must be up here. And if it's up here, it can't be there, so it can only be there. So pause the video, because I'm about to just fill in all the rest of my answers to show you the final solution and see if you can do any more. So there you go, there's my final solution. If you think you can spot anywhere where I've made a mistake, please do let me know, but I'm pretty sure I've got that right. Okay, time to move on. So a semi-cylinder is half of a cylinder. So the volume, we're going to work out the volume of a cylinder that was 75 centimeters high and 20 centimeters for a radius. And what we need to do is work out the area of the circle multiplied by the height. So the volume is pi r squared times the height. So into our calculator we're going to put pi times 20 squared times 75, which should look like this. shift and the button down at the bottom in the middle gives you pi times 20 squared, and you can write it all in one go and then just press equals, and it gives you 30,000 pi, but we need it to 3 significant figures, so if you press S to D, that turns it to a decimal of 9427.78, but this is of course the whole cylinder, and we only want half of it. So if I then divide by 2, and I can do that just by pressing divide, you notice it says ants, that means it'll take that number exactly. Divide that by 2 gives us 15,000 pi, which is 47,123. Well, there's 5 significant figures there, so the first 3 are 471. The 2 means we round down to the 1, and then we still need zeros in as placeholders to show that we're at 47,100, not just 471. Right, so there's part A. Part B, pause the video and have a little go at this. Start by drawing the net. So the net of this cylinder, you are going to have a rectangle for the top. In fact, I'm going to draw it up here so that we can see what's going on. You're going to have the top, and then off the top you've got a semicircle and a semicircle, and then we're going to have a bit like that. Now that distance there is this 75, isn't it? And we want to know the area of the semicircle, but we've got 2 semicircles. Area of 2 semicircles, we've already worked out the area of one of these circles, so we can just use that because 2 of them make the same area as one whole one. And I also know that the diameter of this will be the width of that rectangle, so that won't be 20, it'll be double that, will be 40, won't it? So that bit there will be 40, and then this distance here is going to be half of the circumference. So I'm just going to write a half C there. Then I'm going to redo my little sketch down there and catch up in one moment. So this is where we are at. So I'm going to write down area of circle equals pi r squared again. So that is pi times 20 squared, which we had before. And if you put that in your calculator, it will get 400 pi. I'm not going to hit S to D yet. I'm just going to add it to the rest of it. So that is that and that adding together to make one whole circle. Then we've got 2 rectangles. I'm going to call it rectangle A and rectangle B. So A is going to be length times width, 75 times 40, which is 3,000. And then for B, this is half of the circumference. So the circumference equals pi diameter. So if we want half of the circumference, we're going to do pi times the diameter is 40 divided by 2, or you could just do pi divided by 2, and then that's going to be multiplied by the length. We can get there in one go. I'm going to put that in the calculator just the way it is. So I hit the fraction button and I'm going to do shift pi times 40, go down to the bottom, put a 2 down there, come out of there and put times 75, and then press equals. Gives me 1,500 pi, and then I'm going to add all 3 of these together. So plus 3,000 plus 400 shift pi equals, and that's because we've got that number there, it's come out of being, it's not going to be an exact multiple of pi, so they're just giving us that. And because we want 3 significant figures and you've got 4 significant figures in the whole number, I've written down the whole number first of all, put a little box around it to remind myself to round. So 8, 9. The 9 means this set is going to be closer to 70, so we round the 6 up and we get 8,970 centimeters squared. Right then, so we need the volume of this solid next. Pause the video, make a sketch of it, unless you've done that already. You're going to be doing the volume of the solid. So we need the area of all of this. Volume equals cross-sectional area times the depth. And the depth is 8. And you're going to get a mark. If you have a go at doing something like this and you end up timesing it by 8, having written that down, you definitely get a mark for that, whatever you've got here. Now, I'm going to split this into two parts, A and B. It says this is a half cylinder on a rectangular prism. So I know that half of this distance here is going to be the radius of that. That's important because that radius will also work, I'm going to use a bit of colour here, going straight up there. So half of 2 is 1, so the radius is 1 metre. Now if that's 1, it's been slightly or very confusingly done, because if that's 1, that is 2 metres. So we've actually got 1 metre being represented there and 2 metres being there, making up your 3 metres. Area A is going to be length times width. It's actually a square. 2 times 2 is 4 square metres. Area B is a semicircle. Now, area of a circle is pi r squared. So a semicircle will be a half of that. This is 3 significant figures, so we're using our calculator. So just write a half times pi times r is 1. So it'll be 1 squared equals, pop that into the calculator, 1/2, come out of the fraction, shift pi times 1 squared, which you should know is 1 anyway, and it's giving us a half of pi. Well, let's just keep that as a half of pi for now. And we are going to want to, so the volume is going to be the cross-sectional area, which is 4 plus a half pi. I'm going to use a bracket, and so I'm just going to put that all in there, times by the depth, which is 8. So if we just start typing that into the calculator, that has shown our working for us. Open brackets, 4 add 1/2 shift pi, close brackets, times 8 equals, and it's giving me 44.56. I've just written down the first 4 significant figures because it wants it to 3. So because that's a 6, that's going to nudge that one up to a 6, 44.6 centimeters cubed. Okay, question 9, just trying to find what the radius is if you know what the volume is. So write it down and write down what you would do if you were trying to find the volume. Give it a go. So we know that the volume is the area of the cross section, which is pi r squared, times the height. So let's put in what we know. We know the volume is 507 pi. We also know that the radius they're just calling r, so put in r squared, but the height is 12. So what could we do? Well, we could divide by 12 and the pi. So we're actually going to divide by 12 pi, which gives us 507 pi over 12 pi. And if you were to put that into your calculator, you'll find that the pi's should cancel out. And it gives us 169 over 4. Press S to D and you get 42.25 is what we divided by that, and that is r squared. So then we need the number that you multiply by to get there. So we want the square root of 42.25. The square root of r squared is r. So now if I just press just root, and if I then press answer, it'll put that 42.25 in there. It says 13 over 2, press S to D, it says 6.5, because 6.5 times 6.5 is 42.25. So 6.5 is my answer. Now it is 6.5 meters. If you write that, it doesn't matter, but you do not need units when it says the value of the letter, because the M is there in the question already, and if it said what is the radius, then you would have to say 6.5 meters, but the value of R is 6.5. Right, a very similar question now, only this one is about surface area. So it's going to take a bit more work. Start by sketching out the net and then see if you can put together some kind of an equation for it. So hopefully for a net you have got your two circles and your rectangle. They should be the same size, shouldn't they? So I know that that is 5. I know that I need to find out the height, and I know that the total surface area is 165 pi. So the area of the circle is going to be pi r squared. We know r, it's 5, so it'll be pi times 5 squared, and that's 25 pi. So two circles will be double that, gives us 50 pi. So there's definitely a mark for getting that first of all. And then if that's 50 pi, what they're saying, the rest of the area is the area of rectangle, which we know is the circumference times the height. Now let's work out the circumference then. So circumference is pi times diameter, and the diameter is going to be from there to there is double the 5 is 10. So the circumference is going to be 10 times pi. So the area of the rectangle is going to be 10 pi times the height. So what we're going to have is, if you multiply it, you can then just write that all in one go. 10 pi h. So we can then say 50 pi plus the area of the rectangle, we know is coming to our total area of 165 pi. So if I take the 50 pi from both sides, 10 pi h is going to be 165 take 50 is 115 pi. I can now divide by 10 pi is going to be 115 pi over 10 pi. Well, the pi divided by the pi is cancels out because anything divided by itself is 1. And then we've got 115 divided by 10. And when you divide something by 10, you move the decimal point across. So it's 11.5 meters high. So the value of h is 11.5. And we've just got time for me to say this question here I would like you to have a go at and upload your attempt to me. Now it's going to be quite tricky, but just do what you can, please. So you're covering the area, so it's a surface area question. First thing to do is work out the surface area of that cylinder, and then think, right, how many square meters, how many pots of paint will I need? See how far you can get. Look forward to looking at those. Cheerio.